Hello, class. This is your instructor, Miss Birchfield. In this lesson, we're going to talk about the rules of exponents and some examples of each rule that involve just only the one rule. The first rule we're going to look at is the product rule. And the product rule says that when multiplying terms with the same base, what we're going to do is add the exponents. So just looking at the rule here, our base here is A for both of them, and then we have an exponent M and exponent N. So what we do is we write the common base and we add the exponents together. So here's an example, x to the fifth, and we're going to say times x to the third. So we're going to add the exponents because both of the bases are x's, and we're going to get x to the 8th. And then over in the second example, we can do this for multiple bases. In this case, we have x's and we have y's. So we're going to combine the x base and we're going to add those exponents together. And then we're also going to do the same thing for the y, and we're going to add the exponents together. And we're going to get x to the 11 and then y to the 5th. Now you really don't have to show this step here, but just for this lesson, I like for you to see that's how we come out with those new exponents. Now, why does this rule work? Of course, in math, rules help to simplify things. It makes working math quicker. The rule works if you think about these exponents. Exponent here and here tells us how many of those bases we have. So in this case, if I broke this down, that first x to the 5th means that I have 5 x's, and then the second one means that we have 3 x's, and then if you just count them all up, there's a total of 8. Well, to keep from having to break it down like that, then we can just use this rule and just add to get the total. The second rule is the power rule. The power rule says that if we are raising a power to a power, so what we will do is multiply the exponents. This rule you can use if you look at kind of how this is set up. This rule, to clue you in when to use it, you have a parenthesis in the term, and then you've got an exponent inside and an exponent on the outside of the parentheses. That's how you can clue yourself when to use this power rule. What it says is you're just going to multiply these powers. I'm going to erase that. You're going to multiply this power to a power, and you can get your simplified term. You can do this with multiple bases. In this case, you can apply it to the A and the B. So this first example, we're going to look at, notice what we have. We have these parentheses here, and then we have this exponent on the inside. We have the exponent on the outside. So that should clue you in that we are going to multiply those exponents together, and that's going to give us x to the 15. Same rule applies here. So notice you've got these exponents inside and an exponent outside. But in this case, we have 3 different bases. We have 3, we have x to the 4, and we have y squared. The rule says we will multiply the exponents. In this case, when I look at the bases, my exponent for this 3 is an understood 1. So what we're going to do is we're going to multiply each of these exponents by 2 from here. So that's going to be 3 to the 2nd, x to the 8, y to the 4. And what I'm going to do, 3 to the second power is 9. So that gives us our simplified expression. Now, why does this rule work? I'll go back to this first example. Remember what we said about exponents. This exponent says that I have 3x to the 5th. So if I broke it down and I write it out 3 times, and then of course the 5, that means I have 5 here, I have 5 in the second term, I have 5 in the third term, and if you count them all up, you get 15 total. The third rule is the quotient rule. Quotient rule says that when we're dividing like bases, we will subtract the exponents. Now, when I look here, notice what we're doing. We always subtract the bottom exponent from the top exponent. And then the same rule applies if I have this parentheses with this exponent, I can apply this to both of those. So when we look at the first example, we're going to have x to the 6 minus 3, so we get x to the third power. The second example, we're going to do x to the 12 minus 7, y to the 5 minus 1. This is an understood 1. And we're going to get x to the 5th, y to the 4th. And the third example, we're going to subtract again. We're going to say 4 minus 6. Well, here we end up getting a negative exponent. And we're going to talk about this negative exponent in the next rule. And I'll show you how to take care of the negatives, because that's one thing with these expressions. We always want these to be positive exponents. Why does this rule work? Come back to this first example. There are 6 x's in the numerator. There are 3 x's in the denominator. I'm going to cancel out 3 of the top with the 3 in the bottom. And how many does that leave us? That leaves us with 3. So instead of having to do that all the time, we can just use this rule. So the fourth rule says negative exponents. If we have negative exponents, we want them to be positive. So what we do, if the exponent is in the numerator like it is here, we're going to move it to the denominator and make it positive. Or if it's in the denominator and it's negative, we're going to move it to the numerator. So go back to that one that we did originally, where we got x to the negative 2. What we want to do to make it positive is we're going to move the x down to the bottom. We're going to make it positive 2, and we're going to put a 1 in the numerator, and that is our simplified expression. The second example here, we're going to move the negative from the bottom, the x from the bottom to the numerator, and just make it x to the 5th. And then this third example, what I want to do is make this positive. So I'm going to move this to the bottom. So that would give us x to the positive 3, and then an x with a 1 in the top. And then using your product rule, what we can do now, because we're multiplying, we can add those two x's together, the exponents, to get x to the 4th. Why does this rule work? We'll go back like we did. So go back to this first example. I'm going to break this down. And I'm going to cancel out 4 x's. How many are left? Well, there's 2. Where are the 2? Well, the 2 that we have left are in the denominator. And of course, we have to have something in the numerator. Since everything cancels out, we just have a 1 in the numerator. And that gives us the same thing that we had for this one. The fifth rule just says an exponent. If a base doesn't have an exponent written, that it's an understood 1. So in this case, x has an understood 1. Here the x has an understood 1, the y has an understood 1, and then the 6x, the 6 is an understood 1, and the x is an understood 1. So it's important to think any base, if it doesn't have an exponent written, that it's always understood to be a 1. And our last rule here is the exponent of 0. If we have an exponent that's 0, then the whole term is just equal to 1. So x to the 0, that's just 1. In this case, we have two bases. We have 4, it's an understood 1, and then of course our x is 0. So what we can do, 4 just stays 4, the x to the 0 is 1, so this reduces or simplifies to 4. Here we have the same, it looks similar to this one, these two do. The difference is the parentheses. Go back, remember what I was saying earlier, parentheses, think about the power rule. If I have this term, this 4x in the parentheses, then that means that the 0 is applied to both of those bases. Well, since both of those bases have an exponent of 0, the whole thing is just 1. And then the last thing here, if we look at the quotient rule, if I look at, using the quotient rule, subtracting, notice 5 minus 5 is 0, so this term is simplified to a 1. Kind of to go back, this is kind of why the rule works when you think of 0. Remember, in division, if anything divided by itself is always equal to 1. So x to the 5th is divided by x to the 5th, so it is 1. But showing you this shows you why this, or x to the 0 power, why it comes out as 1. Thank you for listening to this lesson. If you have any questions, just let me know, and have a wonderful day.